So I'm going to try to help you visualize problem number 21. We have to find the potential at different places on a cube if I have 8 charges positioned at the corners of that cube. So here are the 3 situations that we're asked to find. So let's start with the first part. We're asked to find what is the potential at the middle of the cube. So it's going to be at the middle of this box, if you can imagine the middle of it. Let's kind of make it a clear box. So we need to imagine this box. We need to figure out what is the potential at the middle of this. Now to do that, we can kind of think about being at the middle of the box. So let's go to the middle of this box. And I want to know what is the potential due to each of these these 8 corners. So I have a charge at each one of these corners. For this first one, each one of those charges is going to contribute an equal amount. We know that the potential due to one charge is kq over r. So what I really need to find is I need to find how far it is from this corner that I have with this little blue charge all the way to the middle of this box. And to do that, I kind of have to think in 3D. So let's kind of move to the front of the box and get a front view. And I need to go from this corner all the way to the middle of the box. So I need to kind of think about going over, think about going down, and then if we rotate around, we'll think about going into the middle of the box. Okay, so we're going to go step by step. We're going to kind of trace a path along the edges of this box. Okay, so the box has sides of length A. So the distance from one side to the other side is A. So to get to the middle of the box, the very middle, I first need to go to the middle of one of these edges. And so that's going to be a distance A over 2. And then I need to get to the very middle of the box. So I'm going to go in a distance A over 2. And then if I zoom around to look from the side view, I'm at the top of the box, I'm in the middle, so I need to go down to get into the very middle of this box. We're trying to visualize this in 3D, and that's going to be another distance of A over 2. And basically what I'm doing there is I'm drawing a triangle in 3 dimensions. I'm going from the middle of the box all the way out along a diagonal to this corner. So since I'm basically drawing a 3D triangle by going in, by going in, and by going down, I need to kind of do that in using the Pythagorean Theorem. We call it adding in quadrature. So this first one, our distance is going to be A over 2 squared plus A over 2 squared, and then to go down to the middle of the box plus A over 2 squared, and the square root of that to get my hypotenuse of this kind of 3-dimensional triangle that I have to trace. Okay, so that's the first part, and I kind of wrote an explanation of this on the forums. So for the second part, at the center of a cube face. So what this means is here's our cube, again, same cube, and I'm at the center of this cube face. So I want to know what the potential is right here. So I need to know how far it is to get from each of these corners. So from these 4 corners on the front of the box, I'm the same distance. I can imagine going from this corner to the middle. It's going to be that hypotenuse right there. And to get that in terms of parts of the square that I know, parts of the cube I know, I'm going to trace a path again, like I did in the first part. So I'm going to trace from the corner up to the middle. It's going to be A over 2, and then I'm going to go in, and that's going to be another A over 2. And I get the square root of the sum of the squares of that to get this hypotenuse. So I'm using Pythagorean Theorem. A over 2 squared plus A over 2 squared square root gives me the distance from the middle of this cube face to the corner. And I have 4 of those. So I'm going to have 4 times kq over that radius of A over 2 squared plus A over 2 squared square root to get that distance. Then now I need to do it from the back of the cube. Well, the back of the cube is very similar. I can think I do still have to go in, and I have to go down along this back face. Let's see if we can scroll around. So I have to go, first, let's try to think of it as going from this back corner. I have to make it up to the front, up to the front of the cube to get to this little part of the face, the central part of the face, this correct location on my cube. So I'm going to go from this back corner, and I'm going to go up a distance A. And then I need to go to the middle of this cube face. So I need to go down a distance A over 2, and then I need to go in a distance A over 2. So I'm going a squared plus a over 2 squared plus a over 2 squared square root to get the distance from this little spot, the middle of this cube face, and then go diagonally all the way up to this corner. So I'm kind of adding in quadrature. That's a term you can look up and you can read about. But I'm basically tracing a path, squaring each of the distances on those paths, and taking the square root. And that gives me the three-dimensional kind of hypotenuse cut through that I'm getting from this. And finally, we can do that with the very last cube that we're looking at. I want to know what's the potential at the middle of a cube edge. So I have these two corners. These two corners are easy. My distance from this corner to the charge is going to be just a over 2. So, and I have two of those. So 2 times k times q over a over 2. That's the distance from here to here. Now I need to know from the back corner, from the bottom corners. From the bottom corners, I want to go from this corner diagonally across this face to get to the center of this edge. So I can go up a distance a, over a distance a over 2, take the square of both of those and the square root, and that gives me that hypotenuse. So I'm going a squared plus a over 2 squared gives me that hypotenuse. So I have two charges that are that distance. And then I can go around and I can look up at the top. These from the top view, the back corners of this cube. I want to go from this back corner to this portion of the cube. And I can go right along that face up top. So all I need to do here is I need to go distance a squared plus a over 2 squared, and that gives me the diagonal portion right there along that face. Okay, and then the last part, I need to go from this back part of the cube. I need to first, I can go up to the top part of this face, top part of the cube. So that's going to be a distance a squared plus along the edge of the cube to get up to the front, plus another a squared plus an a over 2 squared. Take the square root of that, and that gives me the diagonal from the center of this cube edge all the way down to this corner. Hopefully that helps you to visualize this a little bit better, along with the explanation that I gave on the discussion board.